Ex228, page 581, question 8. Let's have a look at this one. I'm not going to run through this one in detail. I'm going to leave you to do it, but we'll talk about it for a while and help you with it. So we've got an object which is being thrown vertically upwards. So here's our object and it's being thrown up vertically like that with an initial velocity of u. So you can, from our knowledge of objects and the gravity, which is acceleration due to gravity, g equals 9.81, or 9.8 as it says here, 9.8 meters per second squared. But gravity is a force, the weight of the object is a force which is acting downwards, and so weight is the mass times this gravity. So gravity is actually decelerating this thing as it moves upwards, so it's going to be going slower and slower and slower until it comes to a rest, and then it's going to start falling back down again. And we can, if we know the formula that determines how this thing moves, we can work out how far it's moved in any particular time. And in this particular question, we're after how far is this thing, how high is this thing after 3 seconds. So we've got to come up with a particular solution to this differential equation. It is a differential equation because it's got a differential in it and an equal sign. So first of all, we've got to solve that differential equation, get the particular solution because we need the constant, so that we can then put in our value for t and work out how high it is. So we're after a formula of s equals something. So we've got to solve this differential equation to get s equals something. We're given some initial conditions to allow us to find that constant in the integral at the end, and it's saying that if our start position s, so that s is starting, the displacement is starting at that point. So when t equals 0, we're going to say s equals 0. In other words, it's on the ground, or it's at our datum line, if you like. So s equals 0 and t equals 0, get the general solution to the differential equation using this here. U can be thought of as a constant, and g is a constant. So use what we've been doing in the previous questions and your table of standard integrals to come up with that, and then use your final answer to end up with the distance after 3 seconds, which should be this. If you can't get it out, then send me an email and I'll help you with it. Okay.